attributes of polynomials, okay? Something you're really good at that you've done before. If I told you to graph y equals x squared, right? Remember, that's a parabola, right? And the parent function of y equals x cubed. If you cube a positive number, it gets more positive. If you cube a negative number, it gets more negative. Okay. In other words, I can move these around all I want, but they call it the end behavior, right? If I plug in a million into x, it's going to get really positive. If I plug in negative a million, it's going to be positive. They call it the end behavior because the farther out you go on x, the higher and higher they get, right? Okay, same with here. It doesn't matter if I plugged in 10 million. 10 million cubed is going to be way up here positive. And negative 10 million cubed is going to be way down here negative. Do you see? So its end behavior for x squared is positive, and for x cubed, goes opposite directions, right? The next thing I want to talk about. If I had asked you to graph this, it's a parabola, right? We're good at graphing parabolas. You do that a lot in algebra 1. Step 1 would be to factor it. Hence, we're studying factoring because quadratics are coming next, right? You have to factor it first, which would give me x minus 4 and x plus 3. These are called the factors. You have to factor them, okay, so that you can graph it if they're pretty. Right? Your calculator will do it too. But now the reason you graph it is I gave you the factors, but when it's 0 would actually be at the opposite, right? Okay, 4 minus 4 is 0, so at 4 is where x is 0, and at negative 3 is where x is 0. So when you graph, you take the opposite. Thank you. Which there would be your parabola. Alright? Today we're going to graph polynomials. And I'm going to just make this up just because I was just trying to show you something. In other words, if you have x to the 4 plus 2x cubed plus 3x plus 2. Right? And you could come up with all the factors. For example, x plus 3 times x plus 5, x plus 1 times x minus 3. Right? 4 factors. Then you could plot all the points and graph, just like you did with the quadratic. But a quadratic has 2, right? This one has 4. Well, that's going to be weird, right? How are you going to graph with 4 points? Okay? And that's kind of what you have to decide. Now, the other important thing, and we'll get back to this in just a second, but when you graphed this, okay, x minus 4, you went to 4, x plus 3, you went to negative 3. What about a perfect square like this? If I asked you to graph this, it means x plus 3 times x plus 3. Do you agree with me? Which, can we write that as a short x plus 3 squared? How would I graph that? What do I do? It's a parabola. Where do I go? I go to negative 3. And what do I do? Anybody remember? It's a parabola. Yeah.
Like the tip is on.
That's a good job. Yeah. You just touch it. Right? So, when it was a square, it meant that it happened twice. Right? And it looks like this. When it's a single, in other words, you have an exponent of 1, what did it do to the 2 points? It passed what? Move, didn't it? Okay, that's going to be important in just a minute. Right? So let's actually start by labeling our notes attributes of polynomials. And you want to graph the function. You're going to graph a polynomial. You graph lines, you graph quadratics. You never graphed something with anything higher than the power of 2, right? So that's what we're going to do today. Number 1, f of x equals x plus 1 squared times x minus 1 times x minus 3. In our notes, guys, I asked you lots of times to find me the degree of the polynomial, correct? the reason that the degree matters, okay, and I'll put it up here. If you know the degree, for example, x squared, if you have an x squared, I know that it looks like a parabola, right? What about an x to the fourth? What's going to happen at the end of x to the fourth? Do positives get more positive and negatives get more what? What happens if you take a negative 2 and raise it to the fourth power? What's it going to be? Positive. What about x to the sixth? How about x to the eighth? Right. If I put negative 2 in here, it's going to go positive. If I put positive, it's going to be positive, right? So if you have an even exponent, they call it the end behavior, right? If you have an even exponent, way to the negative and way to the positive, it doesn't make any difference. What I plug in, my final answer is going to go what? Positive, right? If I plug in a million, way at the end, it's going to be positive. If I plug in negative million, it's going to be positive. You see what I'm saying? So if your exponent is even, your end behavior is both positive. What about if you have something like x cubed, or x to the fifth, or x to the seventh, or x to the ninth? Negative exponents. What is their end behavior? Positives get more positive, and what happens to negatives? Right. So their end behavior is on the right you go up, and on the left you go down. I'm not real sure what's going to happen in the middle, but I know that the bigger I get, I'm going to go up, and the smaller I get, I'm going to go down. Right? Okay, that's called end behavior. Well, that's the reason you need to know the degree of a polynomial. Because if you can find the degree of the polynomial, right, you can decide what's going to happen on the end. Because the biggest degree is so big that all the other stuff just doesn't matter anymore. Okay, so what is the degree of this polynomial? I heard it. It's what? 2 here. Well, how many here? 1 and how many here? 1. So 2, 1, and 1 make how much? 2 plus 1 plus 1 make 4. Okay? Because if I was going to FOIL all this out, if I FOIL this, what would I get? An x squared, right? So an x squared times an x is how many x's? X cubed. And then I would take my x cubed, multiply by another x, and how many x's would I now have? 4. The highest power is 4. Right? Because I know the highest power is 4, I know the end behavior. Does that make sense? So my end behavior is you're going to go up here and up here. I have no idea what's going to go in the middle, but I know I'm going to end positive. Okay. The next thing that's going to help me graph it is by knowing my zeros. One of the confusing things that you come up with is these right here. These are not zeros. You may know what these are called. Source enough. So no. Factors. These are my factors, not my zeros. Okay? My factors. My zeros are the opposite. Alright, so what are my zeros? Oh, you do know. Come on. This is x plus 1, so what are we going to write? X what? Just like this problem.
Oh, it's fun to touch x minus 1.
These are my factors, right? X minus 4. So in order for it to be 0, I graphed it at 4, right? This 4 minus 4 gave me a 0. This is 3, so my 0 is negative 3. So for here, my factors are x equals negative 1. X equals what here? 1. And x equals 3. Those are your zeros. Okay? Now you have to decide what you're going to do at these stops. Right? Are we going to either A, pass through the stop, or B, touch it and turn? Okay? What decides it? What was the power here? A 2, and I touched and turned, right? What's the power here? And these? A 1, and I crossed it. So, if you have 2. So the power of 2. You're going to actually touch the graph because it really needs to happen twice. If you have a power of 1, you're going to cross it over. And a power of 1, you're going to cross. Take a picture. Let's give it a shot. Here we go. Here's my graph. What are my zeros? Where am I going to stop? At -1 and at 3. Here's my -1. There's my 3. What am I missing? 1. Those are my 3 stops. Agree? Not just 2, right? It's not quadratic anymore. Okay? The next thing that's going to help me is now that I know all my stops on the x-axis, let's find the y-intercept. So to find the y-intercept, I know it's an ordered pair. Who can help me remember how to find the y-intercept? What is an ordered pair? I can glance at an ordered pair and know it's the y-intercept by knowing what? How do I know it's y-intercept? No, I'm looking at points.
X is 0.
Yeah, x is 0. Yes, it is on the y-axis, but by looking at points, you know because x is 0. So let's start there. X is 0. How do I find it then? Go back to your original function, and what are you going to plug in? 0 for x. X is 0. Plug it in and see. So here's my function. I want to find 0. So go back up here to my function, and everywhere you see an x, you're going to plug in a 0. 0 plus 1 squared, 0 minus 1, and 0 minus 3. So f of 0 is 1 squared times -1 times -3. One squared is 1 times -1 times -3 is 3. Okay, so now you have all the stops you need. 0, 3 is on here. Graph it. Do you know how? Nope. No, it's hard, right? But watch. Have you ever played dot to dot, like when you're little, when you have ABCs and you connect the ABCs? That's the same thing. You're just going to connect them, right? So you might want to use a pencil the first time or two to get better at it. But this is the reason. We needed the degree so we know the end behavior. I know my end behavior on this side is going to go up, and I know my end behavior on this side is going to go up. No matter what I do in the middle, I'm going to land going up on both sides. Okay? Now then, I wrote here touch and cross so you knew what to do, right? At 1, which is, let's go in order. Let's look right here. At -1, what did I say we needed to do? Touch. At 1, we need to cross, and here we need to cross. And if you want, you can label here. You can put a little T and a little C and C, if that helps you. Right, and then what you're going to do is you're going to start here. And this spot we're going to cross through. Okay, check, I crossed. We got to go to this dot. What's it tell me to do to this dot? Cross. Well, I got to get to it, so go down and come back. Okay, cross through. Now the y-intercept, you're just going to go through it. What's it say to do to this one? Touch. A touch means, look what it came from, guys. A square. Think about what a square looks like. It's like a U, right? So make your touch. Go down, touch, and then go back up. I didn't land right on my arrow, so I'm going to erase my arrow. But it still started up and ended up. Okay? It gets easier. Let's try another one. F of x equals x minus 2 squared times x plus 1. Why do we need to know? Oh, by the way, your calculators are a great way to check. But when you get ready to do on the test, you can't use a calculator. But please use them to check. You can't use it on this part, because pretty soon we're going to graph when they have imaginary, right? Your calculator can't help you. So you have to know how to do it, right? And on the PSAT, okay, there's problems just like this, right? You have to know without a calculator, right? Now, to graph, why do I need to know the degree? I need to know the degree because I need to know what happens on the the ends. Okay? So what happens on the ends here, my degree is what?
3.
A 2 here, right? This is x squared times another x. You add them 2 and 1 make 3. What's that tell me about the end behavior, guys? What? Up, positive, down, negative. Okay, so you can put that here. Now then, let's talk about the zeros for a second. What are my zeros? Look here, x equals what? 2 and x equals negative 1. And underneath it, I'm going to write what happens there. This is a square, so I touch and turn, right? And this is a 1, power of 1, so I just cross through. Which that'll get me started with my graph. But what's missing now? I'm missing one thing, the y-intercept, okay? So that'll get me started. If you want to go ahead and make your picture, you're going to touch it 2, put a little t there if you want. Cross at negative 1, or c. That's up to you if you want to label that or not. Now find the y-intercept. Oh, you know a y-intercept is that because when you glance at the ordered pair, there's a 0 in it. And the 0 falls in the spot of x. Okay, so plug it in and check. Find f of 0. I'll give you a second to try to graph it on your own. See if you can figure out how to graph. I just got a good question. How to decide if it touches or crosses? Okay, if there's an even exponent, it touches. And back to the reason why, okay, if you aren't sure. Look, the best way for me to explain it would be like this. If I was going to graph this, it means x plus 3 times x plus 3, which is the same as an x plus 3 squared, right, with an even exponent. An even exponent means you would go here and you just touch it. There's only one way. Okay, that's the easiest way. So if you have an even exponent, it's this. Whereas these, if you think about it, okay, negative 4, you just cross through. That's the easiest way for me to look at it with you, I guess. Okay, you can plug in values. Do a little left, a little right, no matter what's going to happen. It's going to turn up, right? Negatives and positives are still going to force it up, so you can touch it and keep going up. That's the other way to think about it. But in other words, look, 2 means you touch, a 1 exponent means you cross. Okay, alright. So then, to graph this, my end behavior here is up, my end behavior here is down. Just follow it. I'm going to touch this, so you touch and turn, go through here, cross, and you end up going down. And erase this because it's too far over. Make sense? Okay, go to the next one. The more you do, the better it gets in here. This is number. And so the first question is, what is the degree of this polynomial? So that I can decide on its end behavior. What's the degree? Right, it's 4. Which means it's an even exponent, right? 2 plus 2 is 4. So I know that my end behavior is going to be increasing on both sides. The next step then is to find your zeros, which are x equals 2 and x equals negative 1. Look at your exponents. Both of these are not going to cross, they're going to touch. you need? You know your x's, now what do you need to know? You know your y. So find it. Plug in 0 for x. Your y-intercept means you have an x for 0. So you want to find f of 0. And let you grab it. Okay, in behavior is up, so I'm going to touch both, so touch and turn. So touch and turn through here, touch and turn, and back up. Makes a W. Right? Everybody okay with that one? Is it easy now? Easier? Try this one. 2 more like this. F of x equals 1/3 times x minus 5 times x plus 2 and x minus 3. What's the degree? 1, 2, 3, right? Foiled it all out. Combine like terms, right? You'd have a cube. X times x times x. Now then, cube means their behavior would be this. Zeros are x equals 5, -2, and 3. And each one actually crosses. Because look, 1, 1, 1. 1 crosses 2 touches. And then you need your y-intercept. 1/3 doesn't do anything, guys, but change your y-intercept and what it looks like. 0 minus 5, 0 plus 2, and 0 minus 2. So 1/3 times 5 times -2 times 3. Wait. Do that right. So you end up with -10. Oh, negative. That's what's missing. There you go. I was missing something. The 3 is negative. There. And the 5. There. That's what I knew. I knew the final answer should be positive 10. Is that what you got? 10. Okay. There. Sorry, guys. Now let's. Okay, crosses all of them. So it's like. like playing dot to dot. Cross, 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 cro just turns out right every time. You wouldn't think that something, you're so used to graphing quadratics, right? You find the roots and you just make a u. Okay, it's kind of cool that you can actually graph polynomials. All you need to know are the roots, all of them, and the end behavior, so that you know how to guide yourself through. Alright, the last one like this. Technically, we have two more problems. One like this, and then one a tiny bit. F of x equals x minus 3, so you have x squared plus 2x plus 1. And the directions would be to graph it. Does anybody see any problems with it? Good. I hear a bunch of things. What's wrong? You could FOIL this, right, and get back to this big polynomial. That's not going to help you graph, right? In standard form, you can't graph in standard form. You have to graph in factored form, correct? So what do I need to do here? You have to graph in factored form. There's one factor. What's wrong with this one? You've got to factor it. Excellent. Okay, so you need to factor this in order to graph it. So you already had an x minus 3. This is x plus 1 times x plus 1, correct? Which we're going to call it x minus 3 times x plus 1 what? Squared. So the degree of the polynomial is how much? Yeah, and it makes sense. An x cubed times an x is x squared times x is x cubed. So the degree is 3. So your end behavior would be this. Your zeros are x equals 3 and x equals negative 1. Okay, there's a 1 here, so at 3 you're going to cross. There's a 2 here, so you're going to touch. Find your y-intercept. Give you a second to grab it. Okay, well, if you're struggling graphing, look at end behavior. You ready? If you're struggling with graphing, here's my advice. Go to 3 and put a little c. You know you're supposed to cross. Go to negative 1 and put a little t. You know you're supposed to touch. That'll help you out. Now then, go ahead and put your end behavior. This is here and this is here. Okay, ready? Let's play dot to dot. You start here, go down towards my first point. It says cross. So what am I going to do here? Cross through. Then it says, now play dot to dot. You got to go through here. Now I've got to touch this, which means you got to turn, touch and turn. There you go. Does that make sense? And the last one's different. So we have to change the direction and everything. So here's the last problem for today. Given the zeros, form a polynomial in standard form. Okay, so we're going backwards. I'm giving you the answers. and I want you to come up with me a standard form. Okay? What does standard form mean? If you're not sure, this is standard form. Okay? In other words, where you just write it all out, highest degree down, x cubed, 2x squared, x, and 6. This is factored form. See the difference? Standard, factored, standard, factored. Okay? So I want it in standard form. What do I have to do before I can get it in standard form? Put it in what form first? Factor. What's it going to look like? If those are my zeros, what are my factors?
Plus 2, -3.
Good, good. X plus 2, x minus 3, and x minus 6. Those are your factors. You might even write that. These are your factored, this is factored form. Because you hope that the directions say put it in factored form, because you can stop there. Okay? But unfortunately, it's not always the case. I want it in standard form. How do I put this in standard form? What do I do? Yeah, use FOIL. Start here and FOIL 2 at a time. You can't FOIL 3 at a time. Find 2 and then go to the third. So FOIL this one first, which is going to give me, some of you can do this in your head. Look, x and x make x squared, right? What is a negative 3x and a positive 2x? So you go out and in. Negative 3x and 2x. Negative 3x and 2x. What's that give us? Negative x. And then negative 6. Now what do you have to do with that? You have to multiply by the last term. Now FOIL that. Combine like terms and you're done. FOIL it. Kind of messy, huh? It is. You're going to do x cubed that's your polynomial. Okay, before you do anything else, just put your pencil down and just listen. Let me talk you backwards. I'll make a complete circle for just a second, okay? Guys, we're really familiar with graphing things like x squared plus 5x plus 6, right? It's just a parabola. We've graphed it for a while. We're not as good at graphing polynomials, but you can, okay? If you see something messy like this, right, and you know one factor, one, like, so let's say I knew x plus 2 is a factor. Okay? I could do some long division, right? Find the other one. Factor it again, and I would have 3 different terms. Once I get my 3 different factors, I can find the roots and just make a picture. That's it. Okay? All right? The assignment